In today's video, we are gonna discuss shifting property. This is under Laplace transformation. If this is your first video, I have tackled a series of functions under Laplace transform, introduction to Laplace transform, a whole lot of them in this same playlist, Engineering Mastery Laplace transformation. Now, this shifting property is another principle that we need to learn. So I will talk about just one type and then maybe later I'll add the remaining. Now, we learned in the beginning, if you have seen my introduction to Laplace transformation, part 1, we learned that the Laplace transform of a function f of t, we learned that L of a function f of t is equal to f of s. This was what we learned. Now, shifting property is saying that what will be the Laplace form for e minus at f of t? Shifting property is saying that the result of this is equal to f into s plus a. This simply means that the f of s function here, wherever you see s, replace s plus a. Remember, this a is coming from here. Now, I repeat, this a is coming from here. Another thing you must notice is that if this side is negative, then there is addition here. And if this side is positive, this side becomes negative. So again, we can also say that the Laplace transform of L of e a t times the function f of t will give us the function f of t into s minus a. Remember, because this side is positive, this side must be negative. So this is the first type of what? Shifting property. So from this analysis, let us take an example and see what shifting property is talking about. We have a function here, the Laplace transform of e minus 2t Cosh 3t. Remember that this is a hyperbolic function and Cosh 3t is standing for the function f of t. This side, or let me pick this one, this side is representing what we have here. So this means that our a is equal to what? 2. Remember, it's not negative 2. 2. Okay, so now how do we know the Laplace transform of Cosh 3t? You need to know. I have done Laplace transform of hyperbolic functions. You can look at that in this playlist. This is now very simple for us to solve. All we need to do is that we find the Laplace transform of the function f of t. Once we are done, we replace s by s plus a, where this a stands for the value we have here. I guess you got that. So first, let's name the function f of t is equal to Cosh 3t. Now, we find the Laplace transform of Cosh 3t. Now, previously, we learned the Laplace transform of Cosh at. And we learned that this result is equal to s over s squared minus a squared. Okay, so now from this analysis, a here is what we have here. So the Laplace transform of Cosh 3t will be equal to what? The proving for this is in the same playlist you find yourself in right now. So this is giving us s over s squared minus 3 squared, giving us s over s squared minus what? 9. So now let's write that here. The next step is wherever we see s, we replace what? S plus a. S plus a. Now, a here is representing the value 2. So wherever we see s, we replace what? S plus what? 2. So now the Laplace transform of the main function is equal to, wherever we see s, we substitute s plus 2. Remember, this side is negative, so we have s plus 2. That is what I have substituted there. All out of s plus 2. Remember, the s here is squared, so we square it, minus 9. Now, you break the denominator down. This is equal to s plus 2 all out of, when we break this down, this is the same as, let me do it for the sake of those who have problem, s plus 2 multiplying s plus 2, okay, minus 9. We expand the denominator. This is very simple, so those of you can finish this. This time this is s squared, this time this plus 2s, 2 times s plus 2s, 2 times 2 plus 4. This is s squared plus this and this, 4s plus 4. Okay, so when you put that here, we are having s plus 2 all over s squared plus 4s plus 4 minus 9. And finally, your result becomes s plus 2 all out of s squared plus 4s minus 5. And this is the Laplace transform of this function. So the result is s plus 2 s squared plus 4s minus 5. This is 5, not s. All right, so now I'll take the second example. Now look at example 2. We have 2e3t sine 3t. Remember, I explained earlier that if this side is positive, then we are having s minus a, where a represents the value 3. Okay, now here we have positive 3, so this is a. This side becomes negative. So we are fixing in s minus a, or s minus 3, into the function f of t. And f of t is sine 3t. So now f of t equal to sine 3t. So now, what is the Laplace transform of sine 3t? Let's come here. If f of t equals sine 80, then the Laplace or the Laplace transform of sine 80 will generate the result a over s squared plus a squared. Please, I have this video there in this playlist. Finding the Laplace transform of sine 80 is there. You can look at that, how to prove this. Now, from this knowledge, Laplace transform of sine 3t will generate the result 3 over s squared plus 3 squared. Remember that this a is representing this value. It's a scalar, okay? Now, we apply this knowledge here. Now, whatever that we have here is a value that is multiplying the whole function. So, we will factorize it out, okay? Now, we find the Laplace transform of 3t sine 3t. Remember these two. We are just going to factorize it out. We finish the calculation and we use it to multiply, okay, this value. So our concentration is here. Now we know the Laplace transform of f of t, which gave us this result. This means that wherever we see s here, we substitute s minus a, where this a is representing the value 3. This result is going to give us 3 over s minus 3. Remember, this 3 is coming from here. Now, this thing is squared, so we square it, plus 3 squared, which is already here, times the value that was given to us here, 2. Now, you continue this by simplifying this side. This time, this will give you 6 out of s minus 3 all square plus 9. You can then simplify this one by getting your final answer as. Now, when you expand this like the way I did the first one, we are having 6 out of s squared minus 6s plus 9. We have plus another 9 here. So this is 6 out of s squared minus 6s plus 18. And this is our final result. So the Laplace transform of this function is giving us 6 out of s squared minus 6s plus 8. You can choose to factorize the 2 out and maintain the 3 here. So that is it for this example. Let's take the next example. So f of t is here. So we have f of t equal to sine 4t. Laplace transform of sine 4t was giving us the result a over s squared plus a squared. And when we substitute the scalar 4, we have 4 over s squared plus 4 squared. Now from this knowledge, wherever we see s, we put in s plus these 2. So Laplace transform of e minus 2t sine 4t will be 4 out of, now watch very carefully, this side is negative, so we replace s plus the value 2. So we have s plus 2, we square it, plus 16 coming from here. So this result is 4 out of s squared plus 4s plus 4. So this result is giving us 4 over s plus 2 times another s plus 2. You already know that. So this is s squared plus 4s plus 4. This plus this will give us what? 20. So we are having 4 out of s squared plus 4s plus 20. And this is our final result. So in this one, I will give you 2 functions. I'll give you just a few seconds to solve it yourself. So I would want you to solve these 2 functions for me. So these are your 2 functions. Find the Laplace transform of e minus 2t cos 3t. And then find the Laplace transform of e 3t sine 2t. Remember, this is a hyperbolic function. You should know the Laplace transform of sine 2t or sine 8t. They are all there in this playlist. Locate them, finish it. So I'm giving you just a few seconds to do this for me. Okay, so by now I'm sure you are done. You pause the video and you finish the work for me. So let's see if you had that correct. So for the first one, for this one, the result will be equal to s plus 2 out of s squared plus 4s plus 13. So this is it. Did you get that? So let's move on to the next one. So this one, the result for this is equal to 2 over s squared plus 6s plus 5. And that is it. So if you were able to get these 2 correct, that means you really understood what we did today. So clap for yourself. You have done well. Anyway, I will end it here and I'll see you in the next one. Please subscribe to this work if you haven't subscribed to this channel and support this project. Thank you.